The next topic, we can estimate the operation. We use the analytical method. Okay, the first method, we use the balance method. Is similar to the second or the first or second lecture. We can apply this equation to find the operation if we have only one unknown. Okay, for example, this we can define operation from this bottom equation. If the test is 0 and Qg is 0, so we can estimate the E is equal to the difference between rainfall and runoff. Okay, based on this equation. Can you look at the next example? A catchment having a catchment area to 20,000 square kilometer. So we can draw the area 20. This one is area 20,480 square meter, and receive rainfall P is 508 millimeter. Can be like this rainfall. And we have surface runoff Q is equal to 142 cubic meter per second. Okay. The question is then, in this case, delta T is, we can use that 1 year. And they want to know what is the E. Say in terms of the millimeter per year, something. Okay. So from the above equation, we can input is a rainfall QS subtract QG subtract E. Start from the bottom equation, and E is equal to operation rate time the time step equal to I delta T subtract QS delta T subtract. In this case, we assume that for 1 year the storage is chain of storage is 0 and no water, so we have one unknown. Okay, so we can estimate E is equal to, from the rainfall 508 millimeter per year, and with time year we will cancel, and for the Q is 142 cubic meter per second, so we have to multiply by the number of the second in a year. In a year we have 365 days, 24 hours, 60 minutes, and 60 seconds per minute. So we divide by the area change to square meter. So above is cubic meter and below is square meter. We multiply by 1,000 to get millimeter. So it's 508. So we got 219. So the operation is 289 millimeter. So this is just the concept of the water balance to show this unknown for E. Okay, so the next method, Next method we call the energy balance equation. So this one we have from the second lecture. We already talked about this equation from water balance energy balance equation. And in this case, we just rearrange this equation to get this. Okay, so the parameter is lambda is mean the latent heat of evaporation, and H is a sensible heat, and G is ground heat. And for N is net radiation, RN. Not writing here. Okay, so net radiation is based on this control volume. Okay. So we can look at the how to use this equation, calculate the evaporation rate using the energy balance using from the open water surface with net radiation is 200 watt per square meter. Air temperature is 25 degrees C. Assume H equal to 0 and G equal to 0. So actually this one start from ER is equal to this one is 0 and 0. So with the third we have to find the latent heat of evaporation is depend on temperature. So we got 2441. And next we find the density of water from 25 degree. In the next physical property of water, 25 degree. Density is 997. So we can use 997 for density substitute in the equation, and the first step we got the unit in terms of meter per second. We have to multiply by number of seconds in a day, okay, and multiply by 1000 to convert to millimeter per day. So we got 7.1 millimeter per day.